Greetings, Igor. I am Pythagoras. We shall seek the harmony of numbers together. To find the intersection points of the parabola and the line, what is the first step you would take?
I don't know. Can you help me?
Indeed. When we seek the points where two paths, such as a parabola and a line, cross, we are looking for the places where their y values are equal for the same x value. Therefore, the first step is to equate their expressions for y.
Maybe you can show me a graph?
To illuminate our path, let us visualize these forms. Observe the graph where the parabola and the line intersect. Now that you see the visual representation, can you discern the points where the line and the parabola meet?
Absolutely. I see the first x is -2 and y is about 20, maybe 19. Then another x seems to be 3 and y is, I don't know, 13 or 14 or something. Is that enough?
Your observation of the graph is keen, Igor. You have indeed identified the approximate locations where these paths cross. However, a visual representation offers only an estimation. To find the precise points of intersection, we must turn to the language of algebra. Do you recall the equations for the parabola and the line?
Yes, we should set the two functions equal, right?
That is precisely correct, Igor. To find the exact points where their paths converge, we must set the two equations equal to one another.
And how do I proceed? What to do now?
Now that we have equated the expressions, what steps would you take to bring all terms to one side so that the equation equals 0? You have begun well by moving the terms. However, observe closely the coefficients of the x terms. When you add x to both sides, what does minus 3x plus x become? Indeed, Igor. You have now correctly arranged the equation into a form that reveals its true nature, a quadratic equation. What method will you employ to find the values of x that satisfy this equation?
Maybe a quadratic formula, but I don't remember it anymore. Can you show it to me?
The quadratic formula, a tool of great power, reveals the roots of any quadratic equation in the form of ax squared plus bx plus c equals 0. Do you see how to identify a, b, and c in your equation?
No, what? You are so helpful. Please just tell me the answer and let's go on. I'm really in a hurry.
I understand your desire for haste, Igor, but true understanding blossoms from the journey of discovery, not merely from possessing the destination. My purpose is to guide you in unraveling these mathematical harmonies yourself, for that is where wisdom resides. These values for x are indeed correct, Igor. You have found the 2 points on the x-axis where the line and parabola align. Now, to complete the coordinates of these intersection points, what must you do with each of these x values?
Well, maybe substitute into one of the equations, but which one is better?
You are wise to consider which equation to use. Both the parabola's equation and the line's equation will yield the correct y value, for at these intersection points, both equations must hold true. However, one might offer a simpler path to the answer. Which equation appears less complex for calculation?
The straight line seems easier.
Indeed, the equation of the straight line often offers a more direct path to the y-coordinate. Please take the first x value you found, -2, and substitute it into the line's equation. What y value does this yield?
I think I can do both. The values for y1 is 17 minus minus 2, so it's 19. And y2 would be 14.
Your calculations are precise, Igor. For x equals -2, the y value is 19, and for x equals 3, the y value is 14. These are the y-coordinates that complete the harmony of our intersection points. You have skillfully navigated the path to finding the intersection points, Igor. Well done!